G'day guys, today we're going to have a chat about pH and more specifically the resulting pH when two solutions are mixed. So hopefully you guys are aware that pH is a measure of how acidic or how basic a solution is, with the pH of 7 being a neutral solution. So let's get to this question and we'll literally just talk our way through it and see how we go about solving it. So it says, what is the resulting pH of a mixture prepared by combining 20 mils of 0.07 moles per litre of sodium hydroxide and 13 mils of 0.09 moles per litre of hydrochloric acid? So we've got a base, we've got an acid. So the first thing that we're going to do whenever we do any kind of combining two solutions together, whether it be working out pH, whether it be most things in chemistry, we're going to write down a formula so we can see what our products are, and we can also see what the molar ratios of acid to base are. So we have an acid, HCl, and we're adding to that a base, sodium hydroxide. And from that we get a salt, NaCl, and water. Cool. So what we can see is this is what's called a neutralization reaction, because the acid and the base neutralize to produce water, which is neither acidic nor basic in these conditions. So what we know that there's a one-to-one relationship with the molar quantities. So we're going to have to now work out what our limiting reagent is, so we can see whether we're going to have acid or base remaining in solution. Okay, so let's go about doing that. Let's just separate that down. So first of all, we're going to work out the number of moles of acid. So the number of moles of hydrochloric acid, and to do this, we're going to use the formula concentration times the volume. And in this case, we have the concentration is 0.09. And the volume is 0.0, because these have to be in litres, it is 0.013. And this is equal to 1.17 times 10 to the negative 3 moles per litre. Oh, sorry, moles, not moles per litre, moles. What we're then going to do is we're going to work out the number of moles of the sodium hydroxide, NaOH. We're also going to use the formula concentration times volume, and in this case the concentration is 0.07, so it's more dilute than the acid, but we have 20 mils of it instead of 13, so we have more of it. And this is going to be 1.4 times 10 to the negative 3 moles. Cool. So what we can then ascertain from this little piece here is if we're reacting a one-to-one, if there's a one-to-one relationship, whatever has the least amount of moles is going to be the limiting reagent. So we can write, therefore, HCl is the limiting dot all the I's, limiting reagent. So what that means is we're going to have some of this left over. So we can just write a note to ourselves, there will be NaOH remaining. Because what's going to happen is this reaction is going to continue until all of the hydrochloric acid is consumed. And what's going to happen is we're going to have some NaOH just left over. And that leftover NaOH is what is going to influence the pH of the solution. So what we're going to do is we have to find out the number of moles of sodium hydroxide remaining. And the way that we're going to be able to do that is quite simple, is we're going to go 1.4 times 10 to the negative 3, subtract 1.17 times 10 to the negative 3, and that leaves us with 2.3 times 10 to the negative 4 moles. Now, what we have to do now is, because to work out pH, let me just use a different colour. The formula for pH is equal to the negative log of the hydrogen ion concentration. So we need a concentration of hydrogen ions in the end. So to get the concentration of hydrogen ions, we're going to be using this formula, which is the hydrogen concentration, hydrogen ion concentration. So this is the dissociation of water. So times the hydroxide ion concentration at 25 degrees and atmospheric pressure, standard atmospheric pressure, is equal to 10 to the negative 14. So first of all, we need to work out what our hydroxide ion concentration is. So we know the number of moles of hydroxide here. So we're going to use that to work out the concentration of hydroxide. So the concentration of OH minus is going to be equal to the number of moles over the volume. The number of moles is this. And the volume is equal to 20 mils plus 13 mils, so 33 mils, or 0.033 litres. And if we jam that into a calculator, we get 6.97 times 10 to the negative 3 moles per litre. Okay, so now we have the hydroxide ion concentration, not just the number of moles. We can then use this relationship to work out the hydrogen ion concentration, because we can only work out pH with the hydrogen ion concentration. So what we're going to do is we're going to take this formula, let's put it over here, and we're going to rearrange it using a little bit of algebra. The hydrogen ion concentration is going to be equal to 10 to the negative 14 divided by the hydroxide ion concentration, which is what we have. Cool. So we're going to work that out. We've got, so the H plus is going to be equal to 10 to the negative 14 divided by what we've just found out, 6.97 times 10 to the negative 3. And that is equal to 1.435 times 10 to the negative 12. Cool. So finally, we can then just go, the pH of this resulting pH of this solution is going to be the negative log of 1.435 times 10 to the negative 12, which is equal to 11.84. So what that means is, it means we're going to be ending up with obviously a basic solution. Okay, so let's just quickly go through what we did. First, we wrote down our formula for the reaction that we were going to have, in this case a neutralization reaction, to work out our molar ratios of acid to base. Once we'd written the equation down, it was quite simple that there was going to be a 1-to-1 ratio. What we then did is we worked out the number of moles of each of them, and as a result we were able to determine what the limiting reagent was. Now, because hydrochloric acid was the limiting reagent, it meant that there would be sodium hydroxide remaining, it means that this was going to cause, well, it was going to affect the pH. So from here we should know that the solution is going to be basic in the end anyway. So then what we had to do was we had to calculate the number of moles of sodium hydroxide that remained. And because we know that pH is equal to the negative log of the hydrogen ion concentration, we needed to work out what the hydroxide ion concentration was. So we worked that out using number of moles divided by volume. And then we used this relationship, the dissociation of water, to then figure out what the hydrogen ion concentration associated with this hydroxide ion concentration was. Once we got that, we could plug it into the pH formula and we come out with a pH of 11.84, which, because it is greater than 7, means that it's basic. So I hope this video helped, guys. If it did, give it a thumbs up. Subscribe to my channel. I don't mind if you post questions that you might be struggling with in your own schoolwork. I need new ideas for problems to solve all the time. So, yeah, I hope to see you guys next time, and until then, catch you later.